In this video, we are going to study the applications of derivatives to analyze the functions. We are going to learn the steps to find local maxima minima using second derivative test and how to check concavity and the point of inflection. We are going to see how we apply the derivatives to check these two parameters for the given function. Before working on these concepts, I would suggest you to go over my previous videos where I have explained the steps to find intervals of increase and decrease and the steps to find local and global maxima minima. In other videos, I have also explained how to get the information about the first and second derivative from the given graph. I have given the links for those videos in the description box below. Okay, now let us start working on these two concepts. First, let us see how the steps are similar for both the procedures. First, we find the first derivative for both of them, whether we need to find local maxima minima by second derivative test or we need to check the concavity. To find local maxima minima, we need to get the critical points, and while getting the critical points, we also consider the points where the function is undefined. In case of a polynomial function, there is no such points where the function is undefined, but if the function is a rational function, then we need to see those points where the function becomes undefined, and those points also considered as the critical points. So for this process, for local maxima minima by second derivative test, we need to get the first derivative and the critical points using the first derivative. But to check concavity and the point of inflection, we need only first derivative. We don't need the critical points here. For the second step, we find the second derivative for local maxima minima, and for concavity as well, we need second derivative. But here we need to do something more. We need to get the possible points of inflection, PPOI. How we get them? For that, we just set the second derivative equals to 0 and solve for x. Just the way we find critical points. And in case of a rational function, we also consider the points where the second derivative is undefined. This happens in case of a rational function. But if it is a polynomial function, then the function won't be undefined anywhere. For the third point, while getting the local maxima and minimum points, we plug in the critical points into second derivative and check the sign of second derivative. At last, we are going to use these rules to get the conclusion. After plugging in the critical points into second derivative, we check the signs of second derivative. If the second derivative is positive, then it would be a local minima. If the second derivative is negative at some critical point, then that would be a local maxima. It's opposite. If you get a positive sign, then it's a minima. If you get a negative sign, then it's a maxima. For the third step, to check concavity, we get the intervals on a number line using the possible points of inflection, and then we check the signs of second derivative on these intervals. For that, we choose any testing points from those intervals and plug in them into the second derivative. And then we are going to use these rules to get the conclusion about concavity. After testing the intervals, if we get the second derivative positive for any interval, that means function would be concave up on that interval, and if the second derivative is negative, that means function would be concave down on that interval. So positive second derivative represent concave up, negative second derivative represent concave down. Finally, the points of inflection. The final points of inflection would be those ones where the concavity changes. It is not necessary that all the possible points of inflection are the final points of inflection. It may happen that at some point concavity doesn't change, so those won't be the points of inflection. Now let us see the difference between these two procedures. For local maxima minima, we find the first derivative and then find the critical points. But for concavity, we only need the first derivative. We don't need the critical points here. For the second step, we find second derivative for both of them. But for concavity, we set the second derivative equals to 0 and solve for x to get the possible points of inflection, to get all PPOI. For the third step, we check the critical points by plugging them into the second derivative to get the local maxima minima. But for concavity, we test the intervals. We check the concavity using these rules. So if the second derivative is positive, it's concave up. For negative, it's concave down. Now let's work on an example to understand the difference between two procedures. I'm going to use the same function as I used earlier so that you are able to see the difference between all the four procedures using the same function. So for the first step, we find the first derivative for both of them, but for local maxima minima, we need to get the critical points. And we get these three critical points to check local maxima minima, whereas we don't need to get the critical points for concavity. We find the second derivative to check local maxima minima, and the second derivative is going to be 12x square minus 4. Here as well we find the second derivative. For concavity we need to get the PPOI. For that we set the second derivative equals to 0 to get all the possible points of inflection and solve for x. Here we get the possible points of inflection as plus minus 1 over square root 3. To check local maxima and minima, we plug in the critical points into the second derivative. So first we plug in negative 1 and we get a positive result. Next we plug in 0, the next critical point. After solving it, we get a negative result. And then we plug in the next critical point, 1. For that we get a positive result. For negative 1, we get a positive value. That means this would be a local minima. If we look at the rules of local maxima minima, we see that where we get the positive result, that would be a local minima, and when we get the negative result, that would be a local maxima. At 0 we get a negative result, so this is going to be a maxima. So here we write the conclusion that there is a local maxima at 0 and local minima at negative 1 and 1, because we got positive result at both these points. For concavity, we draw the number line and get the intervals on this number line using the possible points of inflection. There are two possible points of inflection, negative 1 over root 3 and positive 1 over root 3. 1 over root 3 is approximately 0.6. So we can write that as negative 0.6 and positive 0.6. First we check the first interval from negative infinity to negative 0.6. For that we can use a negative 1 as the testing point. So we are going to plug in negative 1 into the second derivative, 12x square minus 4. That gives us 8, a positive value. So we put a positive sign over there. For the middle interval from negative 0.6 to positive 0.6, we can test a 0, plug in x as 0, negative second derivative. So we put a negative sign over there. For the third interval, we can test a 1, positive 1. We get a positive result for that interval. We put a positive sign over there. Now we can write the conclusion here. So it is concave up from negative infinity to negative 0.6 and 0.6 to infinity. And the function is concave down from negative 0.6 to 0.6. The final POI are those points where the function changes its concavity. We see that the function was concave up from here to here, then it changes its concavity at negative 0.6 and again at positive 0.6. So those 2 points are the final points of inflection. Final points of inflection are negative 1 over root 3 and positive 1 over root 3. For the final answer, we always write the exact values using square roots. We are not supposed to write the approximate value. We used approximate value 0.6 only to test the intervals for our reference, but for the final answer we are supposed to write the exact values. So we can see the difference between two procedures. For local maxima minima, we find the first derivative and get the critical points, then check those critical points by plugging them into the second derivative. Whereas to check concavity, we find the first derivative, then the second derivative, and then setting the second derivative, we get possible points of inflection, PPOI. Using PPOI, we get the intervals on a number line and then check each interval for the concavity. And the points where the function changes its concavity are the final points of inflection. Thanks for watching. Stay tuned for more interesting videos like this. And don't forget to share, like and subscribe.